Hello everybody, welcome to Chapter 5.1, Successive Differences and Arithmetic Sequences. Introduction to Successive Differences and Arithmetic Sequences. Skip counting and multiples can also be used to find the next number in a pattern, and to find the algebraic formula in a pattern. For example, the pattern of multiples of 5 skip every 5. And here we go. So here we have 5, 10, 15, 20, 25, and 30. And as you see, 5 to 10, we have to add 5. 10 to 15, we have to add 5. 15 to 20, we have to add 5. 20 to 25, we add 5. 25 to 30, we add 5. So the pattern helps us to see that the next number is 35, since 30 plus 5 is 35. The algebraic formula for this sequence is y is equal to 5n. The repeating addition of 5 means that we are multiplying by 5. It is easier to start the pattern when we start with n is equal to 0. We will go into this in more depth on the whiteboard. So let us go over to the whiteboard and look at this. We start off with n, and we start off with 0, and in our case we'll 0, 0. And then we'll go 1, 2, 3, 4, 5, 6, 7. So at 1, we had 5. At 2, we had 10. At 3, we had 15. At 4, we had 20. At 5, we have 25. At 6, we had 30. And then we found that the next one at 7 was 35. So we can say that y is equal to 5, because that's what we're adding to each of these numbers, times 7, that's our n, is equal to 35. Another way to write this is to understand that technically we're starting at 0, and we can have y is equal to 5n, since it's always increasing by 5, plus 0. And if you notice that this begins to look very similar to a linear equation. As mentioned on the whiteboard, another way to write this sequence algebraically would be y is equal to 0 plus 5n, where 0 is our starting number, and we keep adding on 5 n number of times. In example number 1, we're asked how would we write the following sequence and what would the next number be. So here is n followed by our sequence. So we want to figure out what this next number will be. So let us go over to the whiteboard and work this one out. We see n is equal to 0, 1, 2, 1, 2, 3, 4, 5, 6, 7. So we're going to make a sequence that consists of 7 numbers. And we start off at 0 is equal to 1. Then we have 6, 11, 16, 21, 26, 31, and this is the one we have to figure out. So we look at this and we see that to get from 1 to 6, we have to add 5. To get from 6 to 11, we have to add 5. And we continue adding 5 to get to each of these numbers. So that means that in order to get our last number, we have to add 5 to 31. So that will be 31 plus 5, which will give us 36. Now, if we use the formula, we look at this, and we try to write a formula for this, like the linear equation I just mentioned, and we find that y is equal to 5n, because we're going up 5 on each place to get to the next number, and plus 1, because at 0, when n is equal to 0, we're starting at 1. So if we replace this n by 7 plus 1, indeed we get 36. 35 plus 1 is equal to 36. Let's review what we just did on the whiteboard. And we saw that each one went up by 5. So the pattern is plus 5, 1 to 6, plus 5, 6 to 11, plus 5, etc. But we started out at 0, where n is equal to 0 is equal to 1. So the sequence still adds 5 on each time, but this time it starts at 1. So this implies our formula is y is equal to 1 plus 5n. Thus, if n is equal to 7, this means we substitute in our formula y is equal to 5 times 7 plus 1, which means that y is equal to 36, since 5 times 7 is 35, plus 1 is 36. In example number 2, we're asked to use successive differences to find the formula for the sequence below and find the next number. So here we label the n's, n from 0 to 7, and here is our sequence, and we're starting at 3, and we're going up to 27, and we want to find n is equal to 7. Let us go over to the whiteboard and work this one out. So in this one, we're actually going to find the formula like we did earlier, but we're actually going to use the formula to find the next number, and then we can check it just by predicting it. So let's do that. So we have n is equal to 0, 1, 2, 3, 4, 5, 6, 7. So we're going to do 7 numbers. And we start at 3. We go 7. Next number is 11. Next is 15. The next is 19. The next is 23. The next is 27. And this is the one we want to predict. So let's look at how much do we have to add to 3 to get 7? Well, we have to add 4. How much to 7? How much do we have to add to 7 to get to 11? We have to add 4, and so on. So for each of these, we have to add 4 to get to the next number. Now they're asking us to find the formula for this. So we see that we're going up, so we're going to say y is equal to 4, because that's the amount we have to add to each number. So we have 4, and then of course we have to figure out what's happening at the n, and that's going to be n, and then here we start out at 3, so that's going to be our formula. So now that we see n is equal to 7, because that's where our blank is, and we have y is equal to 4 times 7 plus 3. So that's equal to 4 times 7, which is 28, plus 3. So that will give us 31. So now we can look at our prediction here and say, well, if we add 4 to 27, indeed we do get 31. So the formula does indeed work. Reviewing what we just did on the whiteboard, we found that each number increases by 4, and we started out with 3. Since the sequence starts at 3 and adds 4 each time, the equation will be y is equal to 3 plus 4x. The next number using the formula will be 3 plus 4 times 7, and we found that is equal to 31, since 4 times 7 is 27, and we add 4 to that, and we get 31. Thank you very much. I hope that you enjoyed this video. Be well, take care, and goodbye for now.